Hi there. As Omilia, we're members of the ELOQUENCE consortium and a Horizon Europe research project building the next generation of conversational AI for safety critical applications. Think about all the kinds of AI assistants that need to work not just in real conditions, but in messy real world environments across different languages, different domains, and with real users who don't always ask questions in a straightforward way. That's the challenge in Eloquence project. And in this video, I will walk you through one of the core questions behind our work: how to build AI systems that are resilient. What actually means to learn from real world data. Before we get into how we solve these problems, it is worth understanding exactly what makes real conversations so difficult for AI systems. Or to be more precise, provide some characteristic difficult cases that like the four ones that you see on the screen. The first challenge is ellipses, when users leave words out because the context makes them feel obvious. And for clothing, is a perfectly natural follow-up question for a human, but for a retrieval system, reading that query in isolation, it is almost completely uninformative. The second is co-reference, when a user refers back to something mentioned earlier using pronouns or shorthand like it, that, or the plan. The system has to track what those references point to across the entire conversation history. The third challenge is contextualization, where the meaning of a query is entirely dependent on the surrounding dialogue. What are my options could mean almost anything. Its interpretation is constructed from the full conversational context, not from the words themselves. And the fourth one that you see on the lower right, perhaps the most subtle, is what we call non-span information, with a specific focus in named entity recognition, obviously. Cases where the answer to a user question is never explicitly stated in any document. It has to be inferred or derived from what is written. No retrieval system that simply matches keywords will ever find it. These four phenomena are not edge cases, apparently. They are the norm in a real human dialogue, and they are precisely what our pipeline is designed to handle. So then, one of the biggest practical obstacles in building conversational AI for world use is something that rarely gets discussed outside of research: the data problem. To train the system to handle complex multi-turn conversations, you need thousands of examples of real conversations grounded in real documents with all the messy human phenomena we talked about earlier. And in most industries, that data simply does not exist. So our approach was, if the data does not exist, build it, and build it intelligently. We start with whatever documents an organization already has: policies, manuals, FAQs, the kind of material actually that already sits on the company server or desk. Rather than using those documents as they are, we first distill them into their most essential building blocks: clean, atomic facts, one idea per statement. Think of it actually as turning a dense textbook chapter into a set of precise, searchable index cards. From those facts, we automatically generate thousands of synthetic conversations, simulated dialogues between a user and an assistant, effectively. And here is the clever part: we generate each user question twice. Once as a clean standalone question, the way you might write it in a survey, and once as a real human would actually say it in a flowing conversation, with shortcuts, with references to things said earlier, with words left out because they feel obvious. This gives us both sides of the problem in one dataset. So in step three, or in the procedure that follows the previous two ones, we then use those paired examples to train a small, efficient rewriting model. A model whose only job is to take the messy, context-dependent version of the question and turn it to the clean version before actually it reaches the retrieval system. The result is a lightweight model that runs fast, costs little, and performs always as well as systems many times its size, at least with regards to the specific task. And finally, with a clean question in hand, the system can search the knowledge base reliably and generate an answer that is grounded in real source material, not invented, not hallucinated, not but traceable back to a specific fact in a specific document. One insight running through all of our experiments like a thread. How can you prepare your documents upstream and more or less secure the impact on everything downstream? Breaking content into precise atomic facts rather than using raw sentences made retrieval better, made answers better, and made the whole pipeline more robust. Sometimes the most important design decision is not which model you use, but actually it is how you prepare the model learns from. So next, everything we have covered so far addresses how a system retrieves and the response. But as we mentioned in the first slide, there is another layer of intelligence that often goes unnoticed. Does the system actually know what it's talking about? Traditional named entity recognition systems, or NERs, are built around a fixed, predefined list of categories, typically a small set like person, location, or organization. The moment something falls outside of that list, a specific car type, a city reference, a temporal expression like sometime next Tuesday, the system is blind upon it. In rapidly changing real world environments, that rigidity is a fundamental limitation. Our framework takes a different approach. Rather than a fixed taxonomy, we maintain a rich, growing catalog of entity types spanning financial information, geographic data, personal identification, temporal expressions, and more. Each entry carries not just a label, but its full definition, its possible values, its synonyms, and its relationships to other entities. A birth date and expiration date are both dates, but they mean very different things in context, and the system knows that. New entity types can be added without training the underlying model, and the system can recognize entirely new types it has never explicitly seen or been trained upon before. By designing the framework was sorry, so designing the framework was not only part of the challenge, as it's more or less apparent. We also needed to prove it works. Through systematic prompt engineering and carefully constructed synthetic datasets, we fine-tuned state-of-the-art language models across a comprehensive range of entity categories, achieving a strong and reliable performance across the vast majority of them. The framework was built specifically with safety-critical dialogue in mind. Environments where recognizing the wrong entity or missing one entirely can have real consequences. Together, these three aspects, breaking free from fixed categories, building rich structured knowledge, and validating rigorously, defined what next generation entity understanding looked like in our case. So, as an epilogue, we can state or argue that eloquence is more about building conversational AI that doesn't just work in the lab. It works for real people in real languages with real documents in situations where getting it wrong actually matters and getting it right has an actual impact. Thank you.